Hello, grade 12s. We're doing maths again, trig revision for you, grade 12. But today I just want us to go back and recap a little bit. Here, we need to make sure that you revise all your basic trigonometry. That's grade 10 and your grade 11. And the next one, you need to make sure that you are able to use compound angle identities and also double angle identities, which is your grade 12 identities. And the next one will be, you have to be able to prove your trig identities. And now with your trig identities, I need to stress the point here. With your trig identities, they give you a question and they've got an answer on that one. You don't deal with that simultaneously. You take one side. You take, for instance, you take the left-hand side, which may be the complicated side, and you make it the same as the right-hand side. Okay? And then you must be able to find the general solution of your trig equations. And mind you, here, with your sine, for instance, sine x or cos x, you must remember the period of sine x and also cos x, that it is 360 degrees with your general solution, and as well as your tan x, the period is 180. But we'll look into that when we're doing the questions. And lastly, for today, you have to recall how to sketch and interpret your graphs of trigonometry, right? So now I just want us to go straight to the questions, right? This is your exam type questions, guys. The question would be, simplify as far as possible. Now, you're given the square root of cos squared theta plus cos squared 90 degrees minus theta plus your cos 2 theta, all divided by 2. So you have to simplify as far as possible. Okay, right. Now, so let's do this problem, guys. Now, you have your cos squared theta. For now, we're not going to do anything to that. Plus, now, I've got cos squared 90 degrees minus theta. Now, remember in your grade 11, if you're given cos of 90 degrees minus or sine 90 degrees minus, remember that 90 degrees minus is your first quadrant, and all the trig ratios are positive in the first quadrant. So now, but because of 90, your cos changes to sine. So you'll have your sine theta there. So because of that square, we're going to have our, this is, you'll have a plus sine squared theta plus. Now, guys, mind you, we said in the beginning of the lesson that with your double angle identities, you must make sure that you keep them here. So you've got your sine 2 theta. Sine 2 theta is 2 sine theta cos theta. And your cos 2 theta, you've got three options. You've got cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Right, and guys, whichever one you use, at the end of the day, you're going to have the same answer. So in this case, I'm going to choose to use 2 cos squared theta minus 1, all divided by 2 under the radical sign. Okay, right? Now, we proceed with our problem. Right, guys, you've got cos squared theta. Now, cos squared theta plus 2 cos squared theta, those two are like terms. So 2 cos squared theta plus 1 cos squared theta, this gives us 3 cos squared theta. All right? So now I have sine squared theta minus 1. Now, guys, here, very important. Remember, if you have sine squared theta plus cos squared theta, this gives us 1. It's an identity. So I can write sine squared theta is 1 minus cos squared theta. Okay? Minus 1, all divided by 2, all under the radical sign. Okay? Now, I now have, again, like terms. I've got 3 cos squared theta minus cos squared theta. So I've got 3 lots of cos squared theta, subtract 1. So that gives us 2 cos squared theta. Now I have a 1 minus 1, which that gives us naught, right? All divided by 2 under the square root. So we have now this 2 divides that 2 equals 2. Now I'm left with the square root of cos squared theta, which is, the final answer is cos of theta. I hope that helps, guys. So you simplify this as far as possible, right? You apply your trig identities. So that is why we said at the beginning of the lesson, you go back to your grade 10 identities, grade 11. So you must make sure that you, before you go write your exam, you have mastered all those, right? So now, guys, I'm going to move on to the next question, right? The question says, simplify without the use of a calculator. Now, we're looking at this question. You've got your cos squared 180 degrees plus x. Now, you must remember your Cartesian plane. You have to picture it, or I suggest when you have this question, you just write your Cartesian plane somewhere. You remind yourself that this is 0 and 360. I've got a 90 degrees there, and then 180, that's not 780, and then the 270. Now, remember, guys, this is your first quadrant, second, third, and your fourth quadrant. Now, you're given this 180 degrees plus, and 180 plus will fall into that quadrant. So 180 plus is the third quadrant, and that is your t quadrant, which is your tan. So the rest is negative, okay? So now, if that is so it means that our cos is negative in that quadrant. And the nice thing about this one now is that you've got a square. This is cos squared 180 degrees plus x. So in other words, you've got cos 180 degrees plus x times the cos 180 degrees plus x. And that should give us a minus cos x times a minus cos x. So our final result here will be your positive cos squared x. Okay? Right? Now let's just get rid of this. Now, we move on. There's a square bracket there. I have a minus, all right? Now, I look at that 360 minus, right? Now, 360 minus is your fourth quadrant, okay? Now, 360 minus is the fourth quadrant. How is tan in the fourth quadrant? Tan is negative in the fourth quadrant. So I'm going to get the negative tan of x. Okay? Right. Multiply by cos of 90 degrees minus. Cos 90 minus is the first quadrant. How is cos in the first quadrant? Cos is positive. But because of that 90, cos changes to sine. So I'll get the sine of x. All right? Minus. Now I have the 90 degrees minus, so here it should be x, right? So you've got 90 degrees minus x. Which quadrant is this? It's the first quadrant. How is sine in the first quadrant? Sine is positive. So you get positive, but then there's a 90 degrees sine changes to cos, so you'll get your cos of x times. Now, you have cos 180 degrees. That's special, right? Or you can just draw a graph of cos. There's 90, 180, and then your y is minus 1. So cos of 180 is negative 1, and then close bracket, right? So now we move on, right? You've got your cos squared x, which stays as cos squared x, bracket. I have a negative times a negative, that gives us a positive. So it's positive tan of x. But now remember your quotient identity. Quotient identity says if I'm given tan of x, so tan x equals to sine x over cos x. So let's write that down. So that is sine x divided by cos of x multiplied by the sine x. Now, here I've got a negative. That's going to times to that negative, which gives us a plus cos of x. Okay? Now, let's move on. I now have cos squared x bracket. Now, guys, remember, this is multiplication of your fractions. So, when you multiply fractions, you've got your numerator by numerator and your denominator by denominator. So, I've got sine x times the sine x, which gives us sine squared x, all divided by cos of x plus the cos of x. All right? I hope we all still following. Now, we move on. You've got your cos squared x bracket. Now, guys, remember, what happens if you've got your fractions and you're adding or subtracting fractions? You need to find your LCD, okay? Now, remember here, you've got a denominator of 1, right? What's our LCD in this case? LCD is cos x times 1, which gives us cos of x, right? Now, we go again, we say cos of x divided by cos x, that gives us 1, times the sine squared x, we get sine squared x, plus the cos x divided by 1, we get a cos x, that's going to multiply with the cos x, that gives us cos squared x. Now, guys, remember, sine squared x plus cos squared x, it's an identity, it equals 2 to 1, all right? So you've got now cos squared x bracket 1 all divided by cos of x. Now, guys, we almost done. Now, remember the top part. This is cos squared x over 1 times 1 over cos x. Now, it means that I've got cos x multiplied by cos x all divided by cos x. So, one cos x divides the other cos x, and then we're left with the cos x. All right, guys, we're now going to take a break, and after the break, we're going to continue with the other trigonometric questions. Welcome back, guys. Before the break, we're busy with some trig questions, and we continue with the trigonometry as well. Nothing else going to be added here. All right, guys, we're now going to move on to the proving of these identities. Now, remember what I said earlier on. You need to take one side, deal with that side, finish it, and then it must be the same as the other side. Okay, so now in this case, I'm looking at the complicated side. And the complicated side is now our left-hand side. Okay, now, so the way you have to do your identities, you've got your left-hand side. So I'm going to take the left-hand side. Left-hand side as sine 15 plus cos 15 times sine 15 plus cos 15. So because of that 2, so it means that we've got two brackets, 2 lots of whatever it's in the bracket. So in other words, I'm just going to expand this so that you can see where this is coming from. So I've got the sine of 15 degrees plus the cos of 15 degrees times the sine of 15 degrees plus cos 15. This is all divided by sine of 15 minus cos 15, close bracket. Then we have sine of 15 again minus cos of 15. Now, guys, you did this in grade 10, and when you were foiling it out, first, outer, inner, and last. But now, remember, this one, if I have x plus y times x plus y, so I'm going to have a middle term here. So this is going to give us x squared plus 2xy plus y squared. Okay? Now, let's look at this. So this is sine squared x, sine squared 15. Now, plus. Now, remember, I have the sine 15 times cos 15 plus the sine 15 times cos 15, which gives us 2, okay, right? That's going to give us 2 sine 15 cos 15, all right? Now, plus our last term, we have the cos 15 times the cos 15, that gives us cos squared 15, all divided by. Now, the same thing. I've got sine 15 minus cos 15, bracket sine 15 minus cos 15. We are going to have a middle term. Now, remember, some people are confusing this. If you've got a plus, let's say I have a plus there, then we're going to have 2 terms because the middle term is going to cancel out. So that was your difference of 2 squares. Okay, so now in this case, I have sine squared 15 minus 2 sine 15 cos 15 plus the cos squared 15. Now, we need to be extra careful here. I have the sine squared 15 plus the cos squared 15. Now, guys, remember, if I've got sine squared x plus cos squared x, that gives us 1, all right? So now I can write that 1. So I have a 1 now from the sine squared 15 plus the cos squared 15. Plus, now, this looks familiar to you guys. You've got 2 sine 15 cos 15. And that's why we're saying you must remember your identity. So this is from your double angle identity. So you've got sine 2x, this gives us 2 sine x cos x. So now this is your sine of 2, and the x in this case is 15. All divided by, now again here, I have sine squared 15 plus the cos squared 15. Now, sine squared x plus cos squared x is 1, so I get a 1 there, minus, again, this is a double angle identity of sine, so this is sine 2 times 15, all right? Now, we move on. We've got 1 plus. Now, guys, here we are allowed to say 2 times 15, that gives us 30, 2 times 15, that gives us 30 as well. So that's 1 plus sine of 30 degrees, all divided by 1 minus sine of 30 degrees. Okay. Now, I now have sine 30. Now remember, sine 30, sine 45, sine 60, those are special angles. So sine of 30, that gives us a half. So I've got 1 plus a half, all divided by 1 minus a half. Now, our next step, you can just use your calculator, natural display, but you've done fractions in grade 3. So you can just say, okay, 2 divided by 2 plus a half, you get 3 divided by 2. Now times, this is going to be divided by a half, because 1 minus half, you get a half. So this is now times by 2 over 1. And then the 2 and the 2 divides, then you get a 3. Now, you go back. This is a proof question. So you need to prove that the left-hand side, when you whack the left-hand side, at the end of the day, it should give you a 3. And that is what we've got. And then you have to conclude by saying, therefore, the identity is true. Therefore, the left-hand side is the same as the right-hand side. Okay. That's that. Now, guys, we're going to move on to the next question, and it is still the proof question, but it's got some double angle identities as well. But now, in this case, you're given cos. Now, again, guys, you can choose to take the left-hand side, because now this one, both of them, they look complicated. So I can choose, you can choose right-hand side or the left-hand side. So I'm choosing the left-hand side again. So I've got the left-hand side is, now, the cos 2 theta. Remember, guys, you've got 3 options for the cos 2 theta. Let me just write them down here. Your cos 2 theta is cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. Now, with a question like this, I also look at what else am I given. I'm given cos theta. If I'm using one of these, at least it should give me a trinomial or something like that. So now if I take this one, as I said earlier, guys, you can choose any. At the end of the day, it's going to give you the same thing, right? So I'm choosing the 2 cos squared theta minus 1. So this is 2 cos squared theta minus 1 plus a cos theta, all divided by. Now, guys, very important. When you're doing identities, you keep your eye on your right-hand side if you are dealing with the left-hand side. Now, I'm looking at my right-hand side. I see this. This is 1 minus cos theta. But on my left-hand side, I'm given the sine squared theta. But I need to get it to cos somehow, all right? But I know that sine squared theta is related to cos squared theta from the squared identity that says sine squared theta plus cos squared theta is equals to 1. So in other words, I can write this as 1 minus cos squared theta. All right. Now, let's look at the top part. If we look at the top part, you've got 2 cos squared theta minus 1 plus cos theta. We can rearrange that and make it a trinomial. So this is 2 cos squared theta plus cos theta minus 1, all divided by 1 minus cos squared theta. We'll come to that one later. Okay. Now, I am now able to factorize this. This is 2 cos theta and then a cos theta. I've got a 1 and a 1. So this is a plus and a minus, all divided by. Now, guys, look at your denominator. You've got 1 minus cos squared theta, right? So 1 minus, that's a difference of 2 squares. I'm sure we all should remember in grade 10 that we were saying, okay, 1 minus cos squared theta, this is 1 minus cos theta times the 1 plus cos theta. And it should take us back to the 1 minus cos squared theta, right? If you multiply it out. Now, next, you've got your cos theta plus 1 and your 1 plus cos theta, which is the same thing. So I can divide that with that. And now I am left with the 2 cos theta minus 1 and the 1 minus cos theta. I go back and check, okay? That is what they wanted me to prove. I've got the 2 cos theta minus 1, all divided by 1 minus cos theta. So it's now the same. The left is the same as the right. Identity is true. So therefore, our left-hand side is the same as our right-hand side. Okay, so you've proved that identity. Now, guys, we're going to move on to a slightly more complicated question, all right? Now, we're doing question 3 now. Remember, this is your revision, guys. You have to make sure that you're focused, you're asking questions where possible, and we assist you. Okay. Now, we given sine 61 equals to the square root of a. We need to find the value of the following, okay? The value of the following in terms of a. Now, guys, it's always suggested that if you're given something like this, you need to use your right angle triangle, all right? Now, this is 61, okay? Now, remember, most questions, like your exam type questions, they will give you something like this, just like that. Sine 61 is the square root of a. Now, you know for a fact that sine is y divided by r. But now I'm not given r. What you need to do is to rewrite this thing. This is sine of 61 equals to the square root of a divided by 1. Now, that is your y divided by r. Okay. Now, so we've got 2. We can work out the other side, which is your x, your adjacent, from Pythagoras. Okay. Now, I've got sine is y over r. So that is the square root of a divided by 1. Now, how do you work out your x? Now, remember, your Pythagoras theorem says, Okay, now I have the x squared plus y squared equals to r squared. Okay, what's given here is y and r, right? So now this is an unknown. Okay, so I've got x squared plus the y is the square root of a. You square that equals to 1 squared, right? So now this is x squared plus, now the square root of a squared, it gives us a equals to 1. So then we've got x squared equals to 1 minus a. So now, therefore, your x is plus or minus the square root of 1 minus a, right? But I've got a plus, it's in the first quadrant. So it means that I have a 1 minus a, the square root 1 minus a there. Now, if we relook at that triangle, if we can complete this triangle, I've got a 90, a 61. Here, I've got a 29 degrees to make it 180 degrees. Now, we come back now. So, you've got that triangle. You come back to your question, all right? Now, this is cos 73 times cos 15 plus the sine 73 times the sine 15. Now, these are your compound angle identities, all right? So, with your compound angle identities, now remember, if you're given cos of x minus y, remember with the cos, there's going to be cos, and then sine, and then the different sign, okay? But now with sine, if you're given sine, it's going to be sine cos, and then cos sine, and then the sine stays as it is. Now, in this case, I've got the cos. So in other words, so this was the expanded form of cos of something. Now, of cos of the first angle, which is the 73 degrees, and then 15 degrees. The sign differs from the original one, so this one was a minus. Now, 73 minus 15, so 73 minus 15, that's 58, okay? Now, we go back. We were given 61. What's the relationship between 61 and 58? We don't find any at the moment, not unless you see it somewhere else. But now I go back to the triangle. Okay, there is 61, there is 29. There is a relationship between 58 and 29. So actually, this is double that. So you've got your cos 2 times 29. All right? Now, remember, with your cos 2x, you've got three options again. So it's cos squared x minus sine squared. If you use any, at the end of the day, you'll get the same thing. So I've been using the 2 cos squared x minus 1. So we can use 1 minus 2 sine squared 29. Now, this is 1 minus 2 sine squared 29. Now, come to your triangle. Where is 29? This is where 29 is, all right? So now, in other words, if I have the 29 here, the opposite is this. Okay, I'm dealing with sine, and the hypotenuse will be that one, okay? So now, the opposite will be the square root of 1 minus a, and then that is squared, okay? So you've got 1 minus 2. Now, bracket again, let's simplify that. It's 1 minus a square root and then squared. That half times the 2, you get a 1, so you've got 1 minus a. And this gives us 1 minus 2 plus 2a, okay? Now, our final answer will be your 2a minus 1. So, our end result will be your 2a minus 1. So, I hope that that helps, okay? Right. Now, we can move on to the other questions. Right. Now, guys, if we are now looking at our general solution. Now, I said earlier on that you must remember the period of sine and the period of cos. It's the same. It's going to repeat every after 360. And then of tan, it is every after 180 degrees. Now, you need to work out the general solution of the following equation. Okay? It looks complicated for now, but if you apply everything that you were taught, for instance, you're given sine 2x, that's a double angle identity. All right? So that we know it is 2 sine x cos x plus the 2 sine x plus the cos squared x plus the cos x is equals to 0. Now, if we go back again to grade 10, now remember, it's very important. Your grade 10, 11 applies here. You look at the factorization here. If you look at your 2 sine x cos x and the 2 sine x, you can factorize by grouping, all right? So you can group these two because there's a common factor there of 2 sine x. Now, what we can do is, all right, so I've got 2 sine x as my common factor, bracket, cos x plus 1 plus, now this one I have a common factor of cos x, all right? So now cos x, bracket, cos x plus 1, okay, equals to naught. Now, again, guys, if we look at this, there's cos x plus 1, there's cos x plus 1, and these two terms are separated by an operation sign plus. So I can take out a common factor again, which is, in this case, your cos x plus 1, right? Bracket, now I'm left with a 2 sine x plus cos x equals to naught, all right? Now, I've got two brackets here. There is this cos x plus 1 and the 2 sine x plus cos x. So this bracket cos x plus 1 is equals to 0, or 2 sine x plus cos x is equals to naught, right? This gives us cos x is minus 1, or 2 sine x is negative cos x. Now I need to pass on this one. Remember, when you're doing your general solution, you make sure that you've got your, it's either sine x equals to something or cos x equals to, or tan x. Now if I look at this one, that there is a sine x on the left hand side, there is also a cos x on the right hand side. But I can work it out and get it to tan x. But how do I get it to tan x? I can divide by cos x where on both sides, right? And then this gives us 2 sine x over cos x equals to negative 1. But also divide by 2 here, right? So therefore, I get tan of x equals to negative half. So now, can you all see that I've got cos x equals to something, and then the tan x equals to something. Now we move on. Now, your general solution is taught in different ways, but I'm going to do the one whereby you need to work out your key angle, right? So you need to find the key angle here, right? How do you work out your key angle? So what you do is, some of you are going to draw a graph here, but let's just do it using a key angle. Now, how do you find the key angle? So you say shift cos, now we use that 1 equals 2, right? So the key angle shift cos of 1 gives us naught. So our key angle in this case is 0. Now, most of you at home can see that I didn't use a minus yet. I said shift cos of 1. So this is a direction. Okay, so I've got the key angle, which is 0 degrees. Now, I come back. Now, I'm using that minus 1. What does this minus 1 tells us? It tells us that cos will be negative somewhere in 2 quadrants. So cos is negative in the 2nd quadrant and also in the 3rd quadrant. So dealing with that cos x equals to minus 1, so I will have x equals to, in the 2nd quadrant, how do I find an angle in the 2nd quadrant? I would say 180 degrees minus my key angle. In this case, it's plus, it's 0. Plus, now, remember the period of cos is 360 degrees times k, where your k is an element of any integer. Okay? Now, so in other words, the first bit of our general solution is 180 degrees plus 360k. And remember, when they ask you to find your x, then you use k, any integer, depending on the restriction that they give you. Okay? Now, now x will be, now again, this is a special one, right? It's going to be 180 plus, which is 180 plus 0. That gives us 180 anyway. So we're left with only this general solution. So this one is fine. It's done. Okay? Now we move on to this one, the tan one. I've got tan x equals to negative half. Now again, same thing that I did. Okay? Let's go back. We say shift tan of a half. Okay, that's 26.57. Okay, key angle is 26.57. Right? Now I've got the key angle. I haven't used the minus. Okay, now the minus is telling me tan is negative in 2 quadrants. So where is tan negative? It's negative in the second quadrant and also in the fourth quadrant. How do I get an angle in the second quadrant? It's 180 minus, because I'm solving for x. So x is 180 degrees minus 26.57 plus. Now remember, the period of tan is different from the sine and cos. So this one is going to be 180 degrees. Okay? Now, so you work it out. You've got 180, okay, let's say minus 180. We get 153.43, 153.43 plus the 180 degrees, okay? And then that last one, now remember, we're saying x is, tan is also negative in the fourth quadrant. So it's going to be your 360 degrees minus 26.57 degrees plus 180k. And then we work it out. 360 minus 26.57, 26.57, and we get that 333.43 degrees plus 180 degrees times k. So that is your general solution. Now, please remember, you've got, it has to be sine x equals 2 or cos x equals 2 or tan x equals 2. Now, guys, after this question, I just want us to take a short break again, get some water or tea, and then we continue with the rest of the questions. Welcome back, guys, on our revision. I hope you had some water and tea and some snacks. Now we continue with our trig problems. Okay? Now we've got to question 5. Answer the following questions without the use of a calculator. Now remember, when they're saying without the use of a calculator, you do not have to use a calculator. Not unless you get to the special angles now, the 30, 60, 45, and you've got a natural display, you can use your calculator from that point. But you don't just punch everything in your calculator. You follow all the steps up until you get to the final answer. Okay? Right. Now, you've got tan 210. Now, what you need to try and do is to get these big degrees into your acute angles, right? Most preferably your what we call your special angles. Right now, so I've got 210, which is close to 180. So this is tan of 180 degrees plus 30. Okay? Multiply by sine of 180 degrees plus 60, right? I am still fine here. I have the 30 and the 60. Those are the special angles. Now I come to 170. I can't get it straight to 30 or 60 or 45. Now, remember, guys, if you don't get it to a special angle, don't panic. Get it to an acute angle. Remember the top part. If I've got, say, for instance, sine 17, there will be a sine 17 at the bottom, all right? So now we proceed with this question. So I get sine of 180 degrees minus 10 degrees, okay? It's all divided by, now this is cos of, now 135, it's 180 degrees minus 45, right, times. Now remember, when you look at your Cartesian plane, I have the plus. If I've got sine plus theta, I get sine theta. Tan plus theta, it's the first quadrant again, so all positive in the first quadrant. Now with the minus, I go straight to the fourth quadrant, going that direction. So if I've got cos of minus theta, that is positive cos theta. All right? Now, if I have tan of minus theta, that's negative tan theta. And if I have sine of minus theta, that is also negative sine theta. So I'm given the sine of minus 45. So this gives us minus sine of 45 degrees, right, times the cos of, now remember what I said earlier, 180 minus, I get 180 minus 10, I get there's some 10 here, and now if I look at the 100, there's 90 degrees plus 10 as well there. So we are covered with the 10, right? Now, we proceed. I've got the tan of 180 plus. Now 180 degrees plus, which quadrant is that? It is the third quadrant, okay? Now, in the third quadrant, how is tan? Remember, all students take coffee. So in the third quadrant, tan is positive. So I get positive tan of 30 degrees times 180 plus, again, it's the third quadrant. How is sine the third quadrant? That's a tan quadrant. So sine is negative. So I get negative sine of 60 times 180 minus, now remember, that's the second quadrant. Sine is positive, so I get positive sine of 10, all divided by, now 180 degrees minus, it is the second quadrant, and it is a sine quadrant, all right? So in other words, your cos is negative, so I get negative cos of 45 degrees, right? Times the negative sine 45 times 90 plus. Now, be extra careful here. You've got 90 degrees plus, that's the second quadrant. How is the given ratio in that quadrant? It is negative. I'm given cos, and it's a sine quadrant, so I'll have that negative, okay? Now, 90, your sine changes to cos, so I've got your sine of 10 degrees, all right? So now we move on. We look at this sine 10, that's going to divide the sine 10, all right? Now, we go on to our signs. I've got a negative here. There's a negative, there's a negative, there's a negative. So in my denominator, I've got a plus. In my numerator, I've got a minus. So minus divided by a plus, I get a negative. Now, guys, as I said earlier, now you must remember the special angle triangle. If you don't, I suggest, again, you use your natural display. You say, okay, now tan of 30 is square root 3 over 3. Then you type it in there. Sorry, root 3 all over 3. Now, times your sine 60, again, then it's going to give us root 3 all over 2, right? And then divide by your cos 45. Cos 45, it's root 2 divided by 2 times your sine 45, it's root 2 all over 2, right? Now we move on. We've got that minus. Now, guys, There's a square root of 3 times the square root of 3. It gives us 3, all divided by 6. Now times, this is going to be 4, all divided by 2. All right, which we can simplify. Now guys, this is 1 over 2, and this is 2 over 1. So our final answer in this case should be your minus 1. Okay, you are given that there is sine of 150 degrees. Okay, you need to prove that sine of 180 degrees can be written as root 3 minus 1 all divided by 2 root 2. All right? Now, we need to use special angles again here. Now, let's just confirm this first before we proceed. Sine of 150, sine of 150 is a half. Now, guys, again, they've given us questions that are impossible. This, if you're given sine of 150, I think they thought they were thinking of sine, let's just double check here, sine of 15. That is root 6 minus root 2 all divided by 4. Now, let's just double check if this works. If I put in the square root of 3, put a 3 there, right? Minus 1 all divided by 2 root of 2, then we say equals to, yes. So now, guys, you need, at home, you need to rectify this question. It should read sine of 15. Sine of 15 is root 3 minus 1 all divided by 2 root 2. Okay? Now, guys, now what do you do in a question like this? You're given sine of 15, you need to show that it is root 3 minus 1. And this question is normally 4 marks to 5 marks. Now you have to make sure that you change that 15, you write it with your special angles, and at the end of the day it should give you your right hand side. Now, so I take the left hand side. This is sine of. Now we take the special angles. We can take 45 degrees minus 30 degrees. Okay? Now, the sine of 45 minus 30, this is sine of 45, okay, cos of 30 minus cos 45 sine of 30 degrees. Okay, so now that is, now remember guys, these are special angles, so you've got sine 45, we know that this gives us root 2 all divided by 2 times the cos of 30, that will be root 3 over 2 minus root 2 over 2 times the sine of 30 is a half. Okay. Now, moving on, we go back, we check, this question needs us to prove that this is root 3 minus 1 all over 2 root 2. Okay? Now, this is root 3 times root 2 minus root 2 all over 4 all over 4. So that, if you put it on the LCD, on one LCD, this gives us all over 4. Do you agree? Right? So now there's a common factor of root 2, right? So that is bracket root of 3 minus 1 all divided by. Now let's check how they want it. They need the root 2 to be at the denominator. So you've got the 4, and the 4 is 2 times 2. Now, guys, in order for that to get to this part, we need to multiply by the square root of 2 divided by the square root of 2. Now, remember, we're rationalizing our numerator. Now, the root 2 times the root 2, this gives us 2 square root of 3 minus 1, all divided by 2 times the root 2, and then the 2 divides the 2, all right? Now, so we are left with the square root of 3 minus 1, all divided by 2 square root of 2, which is now the same as our right-hand side. So we prove that, so therefore the sign of 15, it's equals to the square root of 3 minus 1 all over 2 root 2. The identity is true. So therefore the left-hand side is the same as the right-hand side. So guys, because of time, I need to quickly look at your graphs, right? So we're just gonna run through our graphs, and because we have run out of our time, you've got your three functions. You've got f of x equals to minus sine of half x, and g of x equals to cos x minus 1, and the h of x equals to sine x. Now, guys, before the transformations, I would like us to actually remind ourselves that if I give you a sine graph, the normal graph of sine look like this, right? And then this is y equals to sine x, right? Now, your normal graph of cos, this is your normal graph of cos, right? And then, so you've got y equals to cos, positive cos x, and then your normal graph of tan. You've got your 90 as your asymptotes, 90, and this is minus 90, minus 270, 90 and 270. You've got 180 degrees, minus 180. Then your graph, your positive cos graph, look like this. And then, so these are your mother graphs. So your sine, your cos, and your tan. Right, guys? Because of time, I think we're just going to continue with our graphs and the solutions of triangles the next session. Thank you very much for watching, and goodbye for now.